Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we are from Group 3 from KTSP 3. We want to present question 3, which is involving Chapter 5, Hydrocarbons.
Alright, so to answer the question that was shown to you just now, it asks to draw the structure of J, K, L, M, and N. So our answer for this question is that J is 2-methylpropene, which you can see the structural formula there, and K is 1-butene. For L, it is 2-butene. For M, it is methyl cyclopropane. And for N, it is cyclobutane. Okay, so to explain our answers in the last slide, based on the question gave the molecular formula of C4H8, and it asked for 5 isomers for this formula. So the 5 isomers that we could find were J, 2-methylpropene, K, 1-butene, L, 2-butene, M-methylcyclopropane, and N-cyclobutane, just like what was shown to you just now. So J, K, and L are definitely alkenes, as they will react with bromine in dichloromethane in the dark condition. Meanwhile, M and N is a cyclic structure. J is 2-methylpropene because it has the lowest boiling point, which is -6.9 Celsius, followed by K, 1-butene, which has the boiling point of -6.3 Celsius, and L, 2-butene, with the boiling point of 3.7 Celsius. And the last two are M and N, and they could either be methyl cyclopropane or cyclobutane. Okay, so another part of the question is that it asks why J has the lowest boiling point. And the reason why J is the lowest boiling point is because J, which is 2-methylpropene, has the lowest boiling point as compared with K and L because it has a substituent at the carbon C atom, which is a methyl group attached to it. As you can see right here, there is a methyl group, which is CH3. And because this methyl group exists there, the substituent will give the compound J a lower boiling point. So another part of the question is that it asks us to identify the 2 isomers that give optically active product. So an optically active product is when there is a chiral carbon which has 4 different groups attached to the carbon C atom. So in the question, it is stated that an optically active product can be obtained by reacting the isomers with hydrogen bromide, or HBr. An optically active product only can be obtained when an alkene reacts with hydrogen bromide. So the alkenes that we will be using are J, K, and L. So for J, which is 2-methylpropene, as you can see in this equation here, when 2-methylpropene reacts with hydrogen bromide, it creates 2-bromo-2-methylpropane. And as you can see in the structural formula of 2-bromo-2-methylpropane, there are 3 groups attached to the carbon atom, and these 3 groups are all the same. And the other group is the bromine. So there are only 2 different groups attached to the carbon atom, which means it is not a chiral carbon. And since it is not a chiral carbon, it also does not produce an optically active product. And the next alkene we'll be using here is K, which is 1-butene. So when 1-butene reacts with hydrogen bromide, it creates 2-bromobutane. And In the structural formula of 2-bromobutane, we can see that there is one methyl group, one bromine group, one ethyl group, and one hydrogen group. So there are 4 different groups attached to the carbon atom, which means it is indeed a chiral carbon, and so it does produce an optically active product. And so the last alkane is L, which is 2-butene. So when 2-butene reacts with hydrogen bromide, it creates 2-bromobutane. And in the structural formula of 2-bromobutane, it has one methyl group, one bromine group, one ethyl group, and also one hydrogen group. And so there are again 4 different groups attached to the carbon atom, which means this carbon atom is a chiral carbon and it does produce an optically active product. So the conclusion is that the 2 isomers that can give an optically active product are 1-butene and 2-butene.
Next, write the chemical equation and mechanism that involve. For K, 1-butane, the chemical equation is 1-butane react with hydrogen bromide that will produce 2-bromobutane. So for next is the reaction mechanism for 1-butane. As we know, double bond of alkene is a nucleophilic site that will attract the electrophiles. When the electrophiles added to the alkenes, an electrophilic addition will occur. This addition will involve of 2 steps, which is the first is addition of an electrophiles, and the second step is formation of a product from the carbocation. For the reaction, 1-butane react with hydrogen bromide that in a slow reaction will produce butane plus bromine. For the second step, which is formation of product from carbocation, as we can see, this butane will react with the bromine in a fast reaction that will produce 2-bromobutane. So next, for L is 2-butene. For the chemical equation is 2-butane react with hydrogen bromide that will produce 2-bromobutane. So next, reaction mechanism for 2-butane just same like the previous mechanism, which is involved of electrophilic addition that occur involved of 2 steps. The first step is addition of an electrophile. The reaction is 2-butane react with hydrogen bromide in a slow reaction will produce butane plus bromine. Next, the second step is formation of product from carbocation. The butane react with bromine in a fast reaction that will produce 2-bromobutane.
So we move on to the next one is chemical test to distinguish between J and M. J is an alkene, meanwhile M is a cycloalkene. To distinguish between these two other than using bromine, in dichloromethane in the dark condition, the free radical substitution test can be applied. For the reaction for this test, HV notation is being used to represent light. So we move on to the next one is chemical equation and observation involved. So for J, 2-methylpropene. 2-methylpropene react with bromine with the presence of light. It will produce no reaction. So the observation will be brown color of bromine remain unchanged. So for M, methylcyclopropane. Methylcyclopropane react with bromine with the presence of light. We produce 1-bromobutane plus hydrogen bromide. So for the observation will be brown color of bromine turn to colorless. Draw the structures of the isomer of C4H8 which shows geometrical isomerism. So for the first one is cis-2-butene and the other one is trans-2-butene.
The chosen plant is Ziziphus mauritiana, or called as bidadari tree. Okay, related to Quran verse, we choose an ayat from Surah Al-Waqi'ah that brings means there will be among lot tree with thorn removed. For the explanation, the component in Ziziphus mauritiana is an alkene and a group of isoprenoid polyenes. Okay, then composition of the plant, as you can see, there is 100 gram of ripe Ziziphus mauritiana and 17 gram of carbohydrates and others. Okay, for the benefit of the plant is increased strength, stimulate appetite, enhance liver health and others. Okay, our main reference is our textbook Physical and Organic Chemistry. Okay, other than that, we also refer to Al-Quran and some website. We also refer some journal. As you can see, there is 3 journal as our reference. That's all from me. Thank you.